So you definitely want your green sheet out, and this is going to again sound a bit weird, Aiden, but in theory, I hope you don't learn anything today. What I want to do today is just show you a bunch of different ways we can take this concept of impulse, change in momentum, which is mass times the change in velocity, mv final minus mv initial, because change in anything is? Hey, you got your line. A little stutter there, but you got it. And it's also force times time. And it's also the final momentum minus the initial momentum. Let's see what we can do with that. So example 1 says this. A force of 8 newtons acts on an object for 10 seconds. The mass of an object is 4 kilograms. Okay. Ella over here. What does A want me to find? Yeah, I said magnitude because technically change in momentum is a vector, and when I typed this up, I forgot to put directions in, and rather than retype the question, I just stuck the word magnitude in front of everything, so all we're getting is the size, but not the direction. Zane is yawning, but we'll get her back. What does it want me to find again, Ella? Okay. First thing I would write is my abbrev for change in momentum. I would write that, and then equals. Which way am I going to find the change in momentum, do you think, here, Ella? Look at what they gave you. Good. See it? This is part of the tricky part here, Jada. Looking, because I could also go mv final minus mv. Don't see that. I do see a mass. I see a force and a time. So I would use this version of the impulse equation. It's going to be 8 times 10. Please, Ella, do that in your head without a calculator, please. Yes. Units. It's change in momentum. Change in what? So you could go kilogram meters per second. But I don't know if you remember, I also said you could measure momentum in Newton seconds. If you wrote kilogram meters per second, I would give you full credit. But you notice we went force times time. I would probably, without thinking about it, write that because that's the units that kind of popped out of the equation. But I would totally take kilogram meters per second as well. I'd take either. You can use them interchangeably, but if you're wondering when do I switch, if I used mass and velocity to find the impulse, I'll probably write kilogram meters per second. If I use force and time to find the impulse, I'll probably just, without thinking about it, write Newton seconds. But they're the same units, it turns out. Okay. Cool. What's B want me to find? Good. What's the answer? Too slow. What's the answer? Yeah. 80. Impulse and change in momentum are the same thing, and that's really what this question is asking. Have you realized that if you know the change in momentum, you know the impulse? Do you know the impulse? You know the change in momentum. So 80, and you could again write Newton seconds, or you could write kilogram meters per second. I don't know what direction, but I know that's how big. Okay. Now let's get a little high tech. Scott, what's C want me to find? What's our abbrev for change in? Do you remember? Delta. It wants me to find this. Is there a version of impulse that has a delta V in it? What? Okay, so now I would think to myself, apparently 80 also equals m delta V. That's another way to calculate impulse. How would I get the change in velocity by itself? Let me pause for a second. Got a latecomer. Sorry, Scott. How would I get the delta V by itself? What's the m doing to the delta V? So how do I move the m over? Oh, you know what? It's Scott's theorem, but dividing by m, but this time to get a delta V by itself. So you're telling me, and I think you're correct, the change in velocity is going to be 80 divided by the mass. It's going to be 80 divided by 4. Scott, can you do that in your head without a calculator? 80 divided by 4? Is it 20? Is it 20? What are the units? What would the units be for a change in velocity? Yes. Now, what does that mean? That doesn't mean that we started at 0 and ended at 20. We could have. Or if we started at 5 meters per second, we ended at 25. That's a change in velocity of 20. We could have started at 100 meters per second and ended at 120. Oh, we could have started going backwards at -5 meters per second and ended up going forwards at +15 meters per second. That's a change of 20. So, D says this: if the final velocity was 12 meters per second north, and you know the change in velocity was 20, what was the initial velocity? Ooh. Yeah. So as a number, you could say something like, well, what's changing anything? But you're right. First of all, I'll show you a mathematical way to get there for those of you that like, to do the work. What's changing anything? So you could say to yourself, well, the change in velocity is V final minus V initial. You could say that. Jonah, what's this wanting me to find? I'd like to get the VI by itself. What's right in front of the VI that I don't like? Swappy dance. I mean, we did it in forces. It's still going to work. I'm going to plus the VI over here. I'm going to minus the delta V here. What happens when I do that? I get VI equals V final minus delta V. Emilio, what was V final according to this question? 12. What was the change in velocity? And I get -8 meters per second. And I guess I would live with it if you said that, but how did you choose to interpret a -8 based on a final velocity of 12 north? More specific, can you give me a word that starts with letter S and then has an O and a U and a T and an H? Yeah, you chose to, you said south, right? Not swapping, you said, oh, negative north, south. So if you said that, I'd be good. Or you could say 8 meters per second south. Is that okay, Scott? And I'm hopefully that's not like, wow, that blew my, hopefully that's, yeah, I would figure that out. Okay. Example 2, a snow scooter has a mass of 350 kilograms. A constant force acts on it for 60 seconds. The snow scooter's initial velocity is 2.5 and its final velocity is 18. All right. Jada, what's this question want me to find? What's another word for change in momentum that starts with letter I? Okay, so I'm going to do that. I'm going to go look at my impulse equation on my formula sheet. Which one am I going to use here? Well, I would first see if I can go force times time. Did they give me, Jada, a force and a time? What's the time? What's the force in newtons? So it says 0 newtons somewhere? By the way, Jada, what are they asking me to find in part B? So did they give me the force? Okay, you know what? I can't use force times time. And that's how my brain would have done it. You okay with that? What's the other way? It's m delta v. Did they give me a final velocity and initial velocity? I can do it that way. Look up. Don't write this next bit down. On your formula sheet, because I abbreviated, I wrote it like that. But, Jonah, what's changing? Anything? Write this down. I would go straight to mv final minus mv initial. Jada, what's the mass? Yep. What's v final? Yep. And 3 minus 350. The initial 2.5. Do you see a word like south or north or east or west or forward or backward or anything like that? So I'll just make them both positive and we're going to find a magnitude. Here, I think we need to use our calculator finally. And do you get 5,425? And Jada, if you said Newton seconds, I would be fine with that. Here, because I went mass times velocity, my brain would probably just think, oh, kilogram meters per second. Okay. Jada, what did part B want me to find? Okay. I would have no problem, don't write this down, look up. I would have no problem if you went, well, F equals ma. They gave me the mass. You can find the acceleration. That's totally doable, and I will give you full marks if you do that. However, let's be clever. What did we just find in part A, Jada? Is there a version of change in momentum that has an F for force in it as well? Let's write that down. I would write down, I know that impulse also equals force times time. Do I know the change in momentum? Just found it. Did they give me the time? One line as opposed to several lines. And this is what I said to you yesterday. The impulse equation, it's a nice shortcut. It really is. How would I get the F by itself? How will I move the T over? Yep. Here's another way to find force. It's not just ma, it's also impulse divided by time, apparently. Okay. And you've reached the point where you're not surprised when we see a different way to write something. We've had that happen many times now. I mean, how many equations for acceleration do we have? Lots. So it's going to be 5,425 divided by 60. I can just go answer button divided by 60. The average force must have been 90.4 newtons. What direction? Whatever direction the impulse was, they happen to be in the same. Is that okay? Did you learn anything new? Good. Again, sounds weird, but that's my goal. Okay? Example 3. A rocket of mass, blah, 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 starting from rest, I could probably mentally underline from rest, is acted upon by a net force of that for 120 seconds. What's the final velocity of the rocket? Okay. Look up, put your pencils down, don't write this down. Eric, what is this asking me to find? Okay, I could go like this. VF equals question mark. I know VI. I know T. I need A to find VF. I could then find A because they gave me a force and a mass. I could... Or, Eric, pick your pencil up. Here's where I'm going to argue that that impulse equation is just really, really handy. I'm going to write impulse equals impulse, which sounds kind of dumb. Here's what I'm going to write, actually. I'm going to write force times time equals mv final minus mv initial. You see what I did there? I took two of the impulse equations. I said they got to be equal to each other. And I used Zena's idea that delta is an abbreviation for change in. And I used Jonah's idea that change in anything is final minus initial. Now, why is that so nice? What's VI? Eric, how would I get VF by itself? How will I move the M over? One line and we're there, as opposed to several. Again, my argument is not that you need the impulse equation to do any of this. Do it the long way and I'll give you full credit. But I gotta say, it's kind of a nice shortcut when you really wrap your brain around what's all enclosed in it. So Eric, you're telling me that VF is apparently force times time divided by mass? What's the force in newtons? And the time, 120. And the mass, 2.6 times 10 to the fourth. Okay. What's VF? 3. You get 106? I didn't try and make this one work out evenly. 106. Oh, units, Eric. It's the velocity. Good. So again, the impulse equation lets us take stuff that would normally be 4 or 5 lines and often condense it into one big uber equation and zip zap, we're done. Did you get that okay? I'm sensing you. Are you lying? Sorry? So you didn't get it okay. You didn't get that answer. That's what I'm asking. Did you get that answer on your calculator? No. Okay, don't clear your calculator. Let me pause the video for a second. Example 4. A car of mass 1600 moves at 32 meters per second. What braking force is needed to bring the car to a halt in 1.6 seconds? Again, I would have no problem if you said, oh, they want a force, F equals what? Everybody? And there is enough information there for you to find A. But what I would say is, because they also gave you some velocities and some times, you can combine that all into one equation, the impulse equation. You can say, you know what? Impulse equals impulse. Ooh, what's V final? So you're saying I can cross out that whole term? So what I really have, I'll rewrite it, is this. Ft equals negative m vi. Okay, Cole. They want me to find the force. How would I get the F by itself? Quicker. I guess it's going to be negative m v initial over time. It's going to be negative 1600 times 32 divided by 1.6. What do you get? Now you're going to get a negative answer here. We'll talk about that in a second, but you are going to get a negative answer here. Do you get negative 32,000? Cole, it's a force, units? Good. What's the negative telling me? If the car is going forwards and I want to bring it to a stop, what direction must the force be? Backwards. If the car is going north and I want to bring it to a stop, which way must the force be? South. So I'm okay with that negative, actually. That doesn't creep me out. That says I probably did it right. Okay. Did you learn anything? Good. Nothing. A rock falls from the top of a 40-meter high building and strikes the ground below. What is the force, magnitude, and direction of the ground acting on the rock if it comes to a stop in 0.350 seconds? You know, this looks really similar to the question we just did. They want me to find a force, although this time they said magnitude and direction, okay, from the ground. They gave me a time. I'm going to start out again going impulse equals impulse. Change in momentum equals change in momentum. It says it falls from the top of a building. I think falls from the top of a building, that's like drops. I think I can say that. And so what I really end up with, Aiden, is this. Force times time equals m vf. They want me to find the force. Aiden, which one of these don't I know? Okay. So even though, By the way, how would I get the F by itself? On this line, I'm going to do that. Okay? But now I'm going to kind of draw a little line here, and I'm going to have to figure out VF. Now I'll go full defic mode. I'll go VF equals question mark, VI 0. What else do I know? What else? Do I know time? Is that 3.5 the time that it fell for? No, that's the time it took the ground to bring it to a stop. What else do I know? I got to be fussy. Displacement. So not 40, but... Now, we have just decided that down is negative. And it did say magnitude and direction. So if we get a negative force, down. If we got a positive force, up. Okay. Aiden, which equation? VI is 0. Yay. How to get rid of a squared? Yep. So I get VF equals the square root of 2 times negative 9.8 times negative 40. Square root, answer button. Oh. And I got, did you all get 28? Is that right? Why is it wrong? Okay, this is that time when we take the square root. We know we want the negative root, not the positive one. So negative 28. All right, now I can walk over here. F is going to be M, 2.5. VF, negative 28, divided by T, 0.35. What do you get? When the rock hits the ground, does the ground apply a force down or a force up? Why did we get a negative? Can you see the very subtle mistake we made on the very first line? Okay. I said, well, VI is 0 because we're dropping. Wait a minute. We're talking about the impact on the ground when we hit the ground. You know what's 0 when we hit the ground? VF, after we hit the ground. So what I should have done, and I apologize, I didn't do this on purpose. This was a dumb mistake, and I'm trying to cover it up. Sorry, YouTube, I make mistakes. I should have left this one not crossed out, and I should have crossed out this one. If you can erase that, try to, or just write MVI next to it, cross out that one. And what that's going to do is that's going to give us a negative there, and that's going to be a VI, and a negative there, and I'll have a negative times a negative, which is what? A positive. So this is one time where I made a silly mistake, but Sophie, I looked at my answer and I said, this answer can't be right. The force isn't down. The force has got to be pointing up when you hit the ground, otherwise you wouldn't come to a stop. So I apologize for that, and sorry for those of you on YouTube who are following along too. So, negative 2.5 times negative 28 divided by 0.35. This might work out evenly. Oh yeah, you get negative, positive 200 newtons. So they did say magnitude and direction, so positive, I'll write my direction as up. And then we'll turn the page. How many more of these do I have? A few more. I like example 6. I like example 6. I like example 6. Example 6 is nice. question. A ball moving east hits a wall. The wall exerts a force on the ball. Find the final velocity. So I'm imagining, don't write this down, but as a picture, here's the wall. I'm imagining the ball hits the wall and bounces off. Is that okay? Here's what I really notice. I see the word east. I see the word west. Okay. Madison, we need to let one way be positive and one way be negative. What would you like to be positive, east or west? I don't care. Pick. East is negative. So I'll put a negative there and there. So west is positive. So I'll put a positive there. What does this want me to find? Okay. I would have, again, no problem if you wrote VF equals question mark. VI equals negative that. T equals that. And you can find an acceleration. They gave you a mass. They gave you a force. Or you can do it all in one line with the impulse equation. What's the impulse equation say? Ft equals mvf minus mvi. Madison, what am I trying to get by itself? Yeah. Put a little dot above it right there. What do I need to move over? Well, I guess I need to move this minus VI over. How? Yep. Okay, you know what? First, I think the FT is going to drop down like a domino. And then I would add the MVI. And then how would I get the VF by itself? Here is yet another equation to find VF. I'm not going to memorize this. This is just for this unique situation. I can derive it. If you found that a little scary, again, I have no problem if you use kinematics and forces and ignore the impulse equation. But I think we're good now. What's F? Positive 350. Time is a scalar, 0.0750, plus M is 4.2. V initial, negative 4.65. All over 4.2. What do you get? Nope, I scrolled down a little too far. Definitely brackets around the top. 350 times Mr. Dewick, 0.075 plus 4.2 times negative 4.65 divided by 4.2. Addison, did you get 1.6? No, did I typo? 1.6, 1.6, 1.6? Okay. You're the one that's wrong? Oh. 1.6 what? Units. What did we find? And direction. What did you decide was positive? Because it did say, it said magnitude and direction in brackets there. So, yeah, west. If you had let east be positive and west be negative, we would have done very similar work. We would have had negatives where there's positives, positives where there's negatives. We would have got negative 1.6. We would have got same magnitude, and you would have said negative is west. So either works. Good stretch, Aiden? I know, there's a lot of theory. This is not my most dynamic lesson. I know. Okay. Claudia, what's A want me to find in example 7? What's another word for impulse or another phrase for impulse? change in momentum. Okay, so which version of the impulse equation am I going to use to find the impulse here? Yes. Good. MV final minus MV initial. Although, what's V initial in this question? Gone. Okay. Ooh, what's the mass? Don't say 12. What are the units next to that 12? We'll have to do a conversion. How do I go from grams to kilograms? This might be one that's just worth learning because you grow up in a metric country, and you shop, you grocery shop. You know how you go from grams to kilograms? First of all, kilo is 10 to the what? Or 1,000. Yeah. To go from grams to kilograms, it's divide by 1,000. So I'm going to make a little note here. M equals 12 divided by 1,000, which is 0.012 kilograms. But now we can get the impulse. It's going to be 0.012 times 250. And I get 3 even. 3 what? Kilogram meters per second. If they ask for a direction, pretty sure rifles generally fire bullets forwards. It'd be a pretty badly designed rifle if it fired the bullet backwards. Okay. What does B want me to find, Clothy? Okay. Don't write this down, look up. My first thought was to see, could I go like that? In other words, could I go like that? Did they give me a time? What else did they give me? What haven't I used yet? The length. I could probably find a time from that. There's a VI, a VF. I might just wimp out and find A now. No matter what, I got to find something. So I might go F equals MA, or I might go, in fact, I think I would say I'm going to go F equals MA. Because I can find A here pretty easily. I know VF, 250. I know VI, 0. I know D, 0.85. Which equation, Clothy? VI squared. Let's get the A by itself. So VF squared. Say that again. VF squared minus VI squared all over 2D. You know what? If I was really lazy, I might even just do that. Because now I go straight to plug in the numbers. That's F equals MA, also in disguise, yes? M 0.012. A 250 squared minus 0 squared all over 2 times 0.85. I think I'd do it that way rather than use impulse. 0.012 times bracket 250 squared. I guess I don't need to type the minus 0 squared, but I need to put brackets around the bottom. And I ended up with 441 newtons, but I might be wrong. Or am I good? Yeah. So a little tougher question there, but Claudia, I think in a panic you could have figured it out and kind of, again, made your way through it. I'm hoping you didn't learn anything. Example 8 says this. Consider the diagram at the right for the next 3 questions. In case, it looks like it shows the final and initial velocities of cars after crashing into a brick wall. In case A, the car comes in at 5, bounces off at 4. In case B, the car comes in at 5 and comes to a stop. In which case does the car experience the biggest momentum change? Ooh. Case A, case B, both the same, or I need more information. Should we vote? Yeah? Okay, we'll vote. So, look at case A, look at case B. In which case does the car experience the biggest momentum change? Who says, Mr. Dewick, case A, Mr. Dewick, case A. I got 1, I got 2, I got 3, I got 4, I got 5, I got a 6, I got a 7, I got an 8. Who says case B? I got 1, 2, 3, 4, 5, 6, 7, 8. Got a pretty even split here so far. No, they're both the same. Need more info. Convince me. Eric, what did you go with? What did you vote? B? Convince me. How do I calculate momentum change? It's mass times change in velocity, yeah? So I think the one that undergoes the biggest momentum change, it went through the biggest change in velocity. Jonah, what's change in anything? Final minus initial, final minus initial. Which one of those gives you a bigger answer? A or B? Now we got to pay attention to directions. I would probably let this way be positive, this way be negative, this way be positive, this way be negative. I think here the change in velocity is 0 minus 5, negative 5. Here, negative 4 minus 5. Ooh, negative 9. This has a much bigger magnitude change in velocity. I think this one had a bigger impulse or change in momentum. Bigger change in momentum. I convinced you of that, okay? It went through a bigger change in velocity? All right. So, car A experienced the biggest momentum change. Which one experiences the biggest impulse? You should all know the answer already. Why? Because another word for impulse is what? Change in momentum. A and B, 1 and 2 are the same question, just worded differently. I will try and get you with that on the test somewhere as well. Okay? What is the impulse from the 800 kilogram car? Well, it's going to be mass times change in velocity. And what's the change in velocity? Final minus initial. It just wants the magnitude, so we'll ignore the negative. 800 times 9. I think if you go to your calculator, you'll get negative 7,200 here. So as a magnitude, 7,200. Is that all right? Boy, lots of yawns. I know, this is all thrilling. So, We can now answer some questions, I think. Which types of collisions are worse for passengers? Assume the initial velocities and the time of impact are the same in each situation. What's worse, a head-on collision where the two cars stick together, or a head-on collision where the two cars rebound apart after the impact? Yeah. Why? And because there's more change in velocity, that means there's also more change in momentum. So bigger impulse? Okay. So, why? Rebound means larger change in momentum. That's step one. How can you get a larger change in momentum? That means larger force times time, because that's another way to calculate impulse. But it said assume the time is the same in both situations. So if the time is the same in both situations, what had to get bigger to give you a bigger impulse? What do 3 dots mean? Therefore, larger force. Yeah. Rebounding off of each other, it does much more damage than just pancaking. Okay? You may have noticed this if you've ever watched football, NFL football. The most painful looking tackles aren't the one where they wrap the person up and bring them to a stop. It's where they run through the person and the person suddenly ends up going backwards, rebounds off the tackler. Those are the ones that hurt way more. Why? More impulse. We're almost done. Thank you for your patience. The diagram below depicts the changes in velocity of a ball that undergoes a collision with the wall. Indicate which case, A or B, which case has a bigger change in velocity. What's the change in velocity here? Not 5. What's the change in velocity here? Negative or positive 15 in magnitude, because you have to let one way be positive and one be negative, and it's final minus initial. What's the change in velocity here? 58. Yeah. So which one has a bigger change in velocity? B. Which one would have a bigger acceleration then? Well, also B, because acceleration is change in velocity divided by time, bigger change in velocity. Which one's going to have a bigger impulse? Are you spotting the theme here? B. Which one's going to have a bigger F delta T? B. What's your homework? That was a lot of me talking. I know. So you can try 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The answers are all there. Those will go pretty quick. Number 12. 13 is good. Skip 14. 15 is good. Skip 16. 17 is good. 18 is good. I'll do 19. You can skip 20. You can skip 21. I like 22. You can skip 23. You got about 20 minutes. You can probably get this all done in class.